Hey math kids, today we're going to talk about discovering integrals, and so we'll just jump right in with these examples from the book. Okay, so they give us this, they say find the derivative of this, hence find 2x cubed plus 3x squared dx. Okay, so if we take the derivative of this, we're going to bring the 4 down, x cubed, bring this down, 6x squared. Okay. Now, what they want you to do on this one is they want you to factor out a 2. So we get 2x cubed plus 3x squared. Now notice that this portion is the same thing as this. Okay. So if we want this to look like it, what we can do is we can actually put a 2 in there, and we can cancel the 2 out by doing a 1/2 on the outside. Now we know, since antiderivatives and derivatives are just forward and backward of each other, that this entire piece is just going to be this. Okay. And so I'm going to replace that. So I do 4, or x to the 4th plus 2x cubed. And then I still have my 1/2 on the outside. And so if I distribute that 1/2, I get 1/2 x to the 4th plus x to the 3rd. And so the derivative of all the stuff written in, or sorry, the integral, all the stuff written in white, so ignore these yellow pieces, is just this. Okay? All right. And then we have another one that's kind of like that. So it's cosine of 2x plus pi thirds. And then they want us to find sine of 2x plus pi thirds. Okay. So we want to take the derivative of this first. So the derivative of cosine is negative sine. You rewrite the inside. And then multiply by the derivative of the inside, which is just 2. So that's negative 2 sine 2x plus pi thirds. Then we want to look at how this is different from this. And it's just the negative 2. So if we put a negative 2 in there and then cancel a negative 2 with a negative 1/2, we can take the integral. Okay, so everything right here, so everything except for this negative 1/2 is going to become this. So cosine 2x plus pi thirds, and then I have a negative 1/2 out in front, and that's really all we can do. Now, because a constant would go away when we take the derivative, there technically could be a constant out here, and even on the previous problem, plus c. And so in the next section, we'll see that we'll always add that plus c. That's it for this section. If you need additional help, come to Math Lab. Until then, calculator.